Let's talk a little bit about mod security. Just to give a little bit more details about myself, I'm the lead dev for mod security for the past 8 years, author for the lib mod security. I also do some research on blockchain. That's basically my PhD. I always try to work with multiple things at the same time. So in the PhD, I've studied this blockchain thing. I used to make a lot of contributions on GSM network insecurities, but basically nowadays I'm focused on mod security and mitigate assorted kinds of web attacks and web vulnerabilities. Together with me and mod security, there's a ton of people who work in a project. As an open source project, we receive contributions all around the world. So here is the avatar of some people that make contributions in the project. The guy with the beard is Victor. Victor now lives in Canada. He's basically the co-maintain with mod security together with me. I work for TrustWave. So mod security is a project sponsored by TrustWave. Martin is also in Canada. He is the big picture, round picture here. He helped me a lot on the development of mod security, together with all those other guys from the community that also makes contributions and patches. And I think that's the main reason why mod security is the good software there is today, is because I can count on the community. We can count on the community to make it great and well, add all those features. Today, I would like to talk to you a little bit more about what the good is about version 3.1. But before that, let me give a little brief introduction about this versioning mod security and different versions and different families of mod security. Back when mod security was created more than 10 years ago, 15 years likely, it was only a module for Apache. So basically Apache was the most popular web server there and the only one that was really available in all distributions. So mod security was built to actually target Apache. Later, Nginx became popular and other web servers like IIS became popular as well. So we decided to expand mod security to support those web servers. And we did that doing a little bit of a trick, a hack, right? It's a very hackish way, creating a wrapper for Apache and embedding Apache on IIS or embedding Apache on Nginx. And that was basically the family 2.x for mod security. We had support for IIS, we had support for Nginx, but mainly the code was built for Apache. So it was not so performant, not so stable on Nginx or IIS. On December 2017, we released the first version of mod security 3.0. And mod security 3.0 was a game change because it was a completely rewrite of version 2. And with this completely rewrite, we make mod security a library. And this library adds a lot of possibilities, like put mod security to work together with different web servers and yet make it stable and performant, right? So with the library, create the concept of connectors. So we have different connectors that put mod security to work together with different web servers. We have now a connector for Apache, is still in alpha phase, the connector for 3.0. The Nginx version is well tested. It's been on the market for almost 5 years now and people are using it and they are happy so far. And we have connectors for TCP dump. We have connectors for different kind of network infrastructure. As long as you want to inspect HTTP requests, you can use mod security, lib mod security, and make your own connector. It's very easy. I'm going to show you how we can expand mod security in different script language, in C, whatever you feel comfortable with to code. There is this possibility. And now we are about to release version 3.1.0. It has a lot of new features, and the focus is on usability and how to make easy for writing rules for mod security. What I meant by that is like mod security is just a WAF, web application firewall engine. So it per se, mod security is not capable to actually mitigate and threat. It has to have some rules, and those rules are the ones who actually will use mod security engine to compute things and classify a request as something bad or something okay. So The rules have an important role here as well, together with the engine. Basically, I will focus here on the engine. And one of the reasons that ModSecurity is so popular is the fact that it's very flexible. If you ever try to use a commercial WAF, you have to have a black box installed in your network, or you have to update the DNS of your web server to point to external server, or do some stuff that's not so welcome, let's say. And sometimes it's kind of disruptive in the original architecture that you have for the network. That's different for ModSecurity, because you can deploy ModSecurity as a proxy. You can deploy ModSecurity embedded in your web server. You can also deploy ModSecurity inside your application using script language, if you will. And it has tons of capabilities, like it has native Lua support. There is something called transformations inside ModSecurity that you can use for basically mitigate evasions, like double encode or triple encoding, or what if I have, I don't know, maybe UTF-18 and UTF-16, is that any bypass that could be outcoming of those, then you can use the transformation to mitigate that kind of evasions. You can also do some crazy stuff, like by each request, you can execute the external process, a Python script, a Perl script, and do some processing with that external script and give back the results to ModSecurity to conclude if a certain request should be blocked disruptively or only logged, or, well, sort of different options that we can do. But for 3.1, we do have this improvement of performance, usability, and interoperability. It's interesting to put that way, because you say, well, what performance has to do with security on that aspect? If you think about it, the idea is to inspect the maximum that you can in the shortest time frame, in a way that we can do more inspections and yet does not deliver the results to the user. So that we can deliver content to the user, inspect as fast as I can, do a lot of inspections, and everybody's happy at the end of the day because we're doing good inspection. So that's why we try to make it as fast as possible. That's why it's so important from the security perspective, because there is no point to like a Navy, if you are scanning a file and take like ages. We cannot do that in a web server. People want to have especially with HTTP2, latency is a key thing to deliver the results to the user for the usability. So that's very important. And the usability per se in ModSecurity is like, we want to make easy for people to write rules. If you ever try to use ModSecurity, there are commercial rule set, there are open rule set. One of the most famous ones, the OASCO rule set. And if you open that, there is this rules with a lot of hijacks, very complicated to read and very complicated to maintain. You know, it's a struggle. And we want to have that easy and make it easy for the user to use. Another key is interoperability. We want people to use ModSecurity, make it as flexible as possible. So, if just to give you an example, a few days ago, we had that issue open on GitHub. So the project is on GitHub. I will show you my last slide. I will show you guys all the details. How can you make contributions to the project? How can you use, etc. It will be there. Hold on that. But basically, we had this issue on GitHub, and the user was asking if there is a way to actually parse the rules using Golang. And that's the kind of interoperability that we want to have. We want to have ModSecurity go beyond the web server and actually tackle the scripts language, so that if you are writing your own WAF, or if you try to have protections for a specific web server in the company that you work on, and you want to have an interface so that you can expect the false positives and false negatives, then you can actually use ModSecurity kernel to understand that data and populate your web server accordingly and make it easy for you to expand and implement. So that's an example of what should be interoperability. As a matter of fact, we don't have the Golang yet. We are willing to have. So if you feel like an expert on Golang and want to make some contributions on that issue, you are more than welcome. We will be supporting you to do so. That's the user who actually opened the issue. I think he's moving towards I don't think he have the efforts to actually implement that. So he doesn't have the time available. So we need some effort on that. To give an example, what the kind of thing that we want to accomplish, that's the bindings for Python. So if you use Python, you can actually import ModSecurity and load the rules like we are loading here. And with that, we can parser the rules, and we can also apply some requests atop of it and use Python to process our request. If you are more a C developer than a Python developer, of course you can use the C implementation straight from the library. That's an example to do so. Here we are inspecting suppose connection that's originated by this IP to this web server, and the transaction was requesting this specific URI and passing the headers, body, response headers as the response body. And that's basically what ModSecurity does. If there is any disruptive actions that should be taken in consequence of those inspections, there is a specific method that you can call in the library that will tell you exactly the error code that you have to return and what information that you have to fulfill in your web server or your application to say, hey, that request was blocked, do this or do that. So I was saying performance is a key for do good inspection, because as performant as we go, more inspection we can do. But what is performance after all in that context? Well, usually performance in the context of WAF leads to 4 different topics, which is latency. I already talked to you about a little bit about latency. Latency is how long the request takes to be inspected, or how long the request takes to be delivered to the user at the time that the user actually requests a website. Throughput is the maximum amount of data that your web server can put for clients, right? So if you put a WAF, sometimes it reduces the throughput, because if you think only to deliver content, there is no CPU being used. But if you start to do processing like an analyze or decoding strings, encoding strings, that will add a CPU usage on top of it, and that will reduce the throughput of the server. We don't want the throughput to be reduced at a point that we cannot do the inspections. Memory footprint, that's important to a very specific use case scenario. Imagine that you are working a server provider that has thousands of web servers hosted. If you have like ModSecurity runs in each of one of those, it's very likely that memory will be a concern, because you cannot put so many data on the memory, multiply it by all those sites. It will be a nightmare to manage. And of course, request per second. There is basically, we have to deliver the maximum amount of requests per second that we can. And sometimes that's confusing with throughput. And throughput and request per second, they are somewhat related, but not really dependent. For instance, the user can be download a 1 megabyte file, or there can be download a 10K GIF file. And in that sense, the throughput and RPS, request per second, will be differently, because the web server will deliver the GIF fast, and it will be able to answer for the next request for the next GIF, and so on. So those are the distinctions of both. In a WAF, we have to take into consideration those 4 aspects, either developing the engine or developing the rules. They all depend. And well, how it looks like when we are developing ModSecurity or developing rules, how inspect those, how we observe. So that's a screenshot for our internal system for rules development and for the engine development, where we classify the amount of requests per second that we are having. So that's basically the beginning of the development of 3.1. And now we're about to finish, we are here. So as you can see, we have increased the amount of requests per second. We are now in a relatively good shape. So, and that's what we see. We came up with what's supposed to be a regular traffic for a specific website, and we keep sending those in different servers, and we calculate those numbers, and we make sure to use the same scenario to test different versions, either for the rules or for our engine. We do the same thing, of course, for latency, and that's each point is a commit in ModSecurity 3.1 code, right? We have the strong heads, the maximum latency, and the light one is the minimum, and the middle is the average. And of course, here the minimum the better, the lower the better. And what we have here is a latency way lower than what's supposed to be in the beginning of the development of 3.1. That's amazing because we are doing the same amount of the inspection with less time. So it's very likely that by the end we finish the development, it will be around here, but yet doing so much inspection. And that inspection will lead to be a more effective protection with less latency. That's the general idea. And if you pay attention to the chart, you see that some commits increase a lot the latency. That's normal. That's normal during the development cycle of ModSecurity, because sometimes we are testing. Sometimes we are just we know that a change will be a 2 steps back, or a step back, but we want to have that step back to do 2 step forwards afterwards. So that's necessary. But the important thing to notice is the long-term goal. That's basically the memory footprint. So each bar is a different commit, and that's the beginning of the development, that's the end of the development. So as you can see here, we all have almost the same amount of rules, same amount of memory used by the same amount of rules. No big change on that area yet. We are planning to have more modifications in order to have it even better. That here is very likely to be an error in the code, and ModSecurity failed to work as expected to work. So that's why we have so low memory usage here. And we do have some other problems here and here as well. But that's what we saw. As a matter of fact, it's a Grafana chart like this one. So we can actually select the specific version from the Nginx, the connector version, which rules we are using to test, if it's OWASP rule set, the version. If it's our commercial rules, then we can select the version here as well. And it plots all this data for us. So if you guys have interesting to see this chart, I can show you after the talk via GitHub, or it's open source, so you can actually participate and check this chart by yourselves and do suggestions how to improve and how to make the process better. That's the idea, how to improve the performance of ModSecurity for both rules and engine. Going a little bit over the usability of the ModSecurity, with this new version, it's possible to actually reload the rules live. So prior to that, the user had to actually reload the web server or restart the web server to reload the rules. That's a simple example to show you guys how the user can do it nowadays. Instead of reload the web server just by editing the rule file, the rule will be updated and it will be loaded automatically by ModSecurity and give you protection for the website. That's very important, because imagine that you are surfing a TOS and you want to block a particular IP address. So before, you had to restart your web server or reload the web server. Nowadays, just create a single rule saying, hey, block all the requests came in from that IP address, and the rules will be reloaded and will be applied, and the request will be blocked in a minute that you save the file. So that's a big change. The code is there. We don't know if we're make default in the installation or if there is a configuration flag to enable it or not, because we feel like we didn't have so many people testing it yet. So if you guys want to contribute in ModSecurity and actually test the configurations to see if that feature is working, it will be very good for us to receive your feedback on that matter, because we are avoiding to enable a feature because we feel like we need more testing and more use bases saying, hey, this is okay, it's working fine. You know, if you have that, I don't know, maybe this world server that HP UX or any kind of weird machine in your home, maybe a watch that you are not using anymore that's running Linux in an ARM, and you want to run ModSecurity on that, that's an ideal case scenario for us. We don't have a target platform. We used to say that ModSecurity can run in any platform, even in your watch. So it's still valid test case. If you want to go for it, go for it. It will be amazing to have feedback if it's working or not. Of course, we have to be care about the configuration reload, because the configuration can be bad return and lead to an error. And here is just an example. If you ever use ModSecurity, it's very common if you include in the rules, include the director twice, and that's lead to an error that same rule ID is used twice. Not cool, and sometimes it was very annoying to find where the error was. So let me move forward here a little bit so I can show you guys that basically the new version tells you exactly which file and which line of the file there is this clash of rule ID, or if the rules are misbehaving, it's going to tell you, hey, we have an error in this specific file, this specific line. That was kind of a need. We need to do that in order to reload the rules so that we can make a graceful error message in case there is a problem. If you are wondering what happens in production, well, if you load the rules and the syntax is not well formed, then it won't reload. It will keep the old version of the rule and tell you exactly what the problem was. Big change in the past. I'm sure that the users that use ModSecurity a lot will be very happy to have that, because it was very annoying to investigate where the star was used to include multiple rules from multiple directors with same IDs. Another thing that is very important on this usability is make easy for you to write rules. If you are a pen tester, you find a vulnerability, you are doing a pen test, you find a vulnerability on your client website, and you want to have a hotfix for that, a patch. You don't necessarily need to patch the code of the application to have it available. No, you can create a ModSecurity rule for that and fix the issue by creating this ModSecurity rule and deploy that as fast as possible. It's like a ModSecurity reload, or if you're using this reload feature, just edit the file and save. The hotfix will be there. But in the past was like this. The user had to write a regular expression that was matching something in the request, or the user has to understand all the logic behind the application in order to write the rules. Now we are using lib injection, and the user can only detect SQLI or detect cross-site script using the args. Is a collection that contains all the parameters from the request, for instance. And ModSecurity will work on this content and verify if there is something that looks like a SQLI or a cross-site scripting, and therefore blocking. Lib injections is part of ModSecurity now, but it is an independent project. As a matter of fact, I am Nick, Client 9 was the original author for lib injection. He opened a company for sell WAF products, etc. So he's not maintaining the project anymore. So he passed the project over me. So I am now the maintaining of the project with good friends Victor, Jorge Pereira, and Miguel de Moura. They are also working. Miguel is in Portugal, Victor in Canada. Jorge is here in Brazil, and I am in Brazil as well. So there's another project that needs a lot of contributions, and not sure if you guys ever heard about lib injection, but there is something you can get the details on GitHub. But what lib injection does is actually try to identify payloads inside regular text. So if you go over the website, you can actually send some payloads to test lib injection. And something new that we are actually deployed today is the lib injection bot on Telegram. So if you have a Telegram, if you add this lib injection bot user, you can send text to this bot, and the bot tells you if there is a SQL injection or a cross-site script on the text that you have sent. That's something that we did just for Bsides. So that's something new that came up of the conference. So use, of course, all the payloads that you are using, it's been logged for the sense that we don't want to blame you, just want to make lib injection better. So if you found a bypass, if you send something that is a cross-site scripting or is a scale injection and limb injection doesn't feel so, it tells you it's not, report to us, because we'll be very pleasant to fix. Or if you want to be involved in the fix, you can also report. We help you to develop the fix for that. So it will be something cool, because you can test your payload and yet you help the project to get better. And all this development, all these features is of course added with a security constraints in mind. So we run the fuzzer and the AFL fuzzer on our code. So we actually have a specific compilation for that. So if you try to, we are tackle security here in all different aspects. I was talking about web security. Now I'm going to talk about buffer overflow, heifer overflow, and that kind of stuff. So if you want to test ModSecurity code, the AFL fuzzer, it's on the configuration options. You can enable that and start to test the code. We can also make our framework better. And of course, please send contributions for us. If you find a vulnerability, please do tell. We are going to give you all the credits for that. But the idea here is really to show that we care about security, and we have been testing our code a lot. It's specific machine that's interested. It's just testing ModSecurity, and it's testing for months now. This is just a screenshot, the example of the day that we put the machine to work. That's long ago. It's already showed to us some things that need to be fixed. Nothing, no serious bug yet was shown by that framework, because it was minor things in memory management that needs to be fixed and was fixed already. But feel free to use, test, and report back if you think that you have contributions to do. And remember that what makes ModSecurity project a cool project and a nice project is the fact that we can count on the contributions. And the contributions is the key here. You're thinking, your different perspective on how to mitigate web threats or how to identify those threats. It's very important. Participate in our project. You are more than welcome. There's tons of research around the world that does that, and they're working together with ModSecurity. So even if you are new to pen test, or if you are new to this, I want to be more in the security side than the attack side, the protection side. So you're more than welcome, because then you'll be for sure you'll have big guidance from the guys from the community that is on the whole more than some of us, and can help us understand and make our ideas more sharp, let's say. That's the project roadmap. It's all on GitHub. So that's the version for 3.1. We think ahead, so we already have a milestone for 3.1.1, and it already some issues. So if you have an idea, you don't know how to mock that idea, feel free to go over to GitHub, open a ticket, we'll classify that for you, the correct version, we discuss, and give all the feedback that we can. It will be amazing to have you participate on that. Recently, as you can see by that presentation, we did major modifications in ModSecurity along the years, along the months, specifically these last months. And sometimes this changes is misunderstanding. So example of the CVE, well, this CVE that you're seeing on the screen, there is an issue in GitHub. If you want to have more further information on that, the issue is there. If you want to discuss your security background or your development background, how we can treat that issues, how can we avoid that kind of issues to happen in the future. Just to give you a little bit overhead here, that issue, we dispute that issue. So we don't think it's an issue on ModSecurity, but we are open-minded. So if you think differently and want to participate in the discussion, or if you want to corroborate with our idea that it's not an issue, feel free to jump in the discussion. And with that, I would like to thank you for having me here. It's really a pleasure. Like I said, unfortunately, I'm not there with you guys. It will be amazing here to be in Chile right now. And that's it. And fork the